Now next topic is applying identities. So we have learned different identities. A plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. A square minus b square is equal to a plus b into a minus b. A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Then finally we have seen x plus a into x plus b. X square plus a plus b, that is the sum of 2 into x, plus ab, that is the product of 2. So these are the 5 identities we have learned till now, and we are going to use these identities and we will solve some of the problems. Okay, so now we are going to look at some solutions based on identities. So let's start off with your first question. You need to use the identity and you need to find the value 2x plus 3y whole square. What is the value of it? Okay. So the moment you see this is of the form a plus b whole square. So you can write a plus b whole square is equal to a square plus 2ab plus b square. Now you substitute for a and b. Okay, so here it is 2x as a, 3y as b. So you can write it as 2x square plus 2 into 2x into 3y plus b square means 3y whole square. Now if you simplify, you will get 2x square means 4x square plus you can simply multiply 2 into 2 into 3, that is 12, and then xy 12xy plus 3 square is 9y square, so 9y square, and that's how you will simplify. So we applied a plus b whole square here. Now next question, by using the identity you need to find 103 whole square. You can easily find with the method that we have discussed in squares. What is that? You add extra, that means plus 3, you will get 106, then 3 square, you get 9, you add 0, so your answer is 10609. But here you need to find it by using the identity. So let's see how we are going to do it. Okay, so 103 whole square. Now what you can do is you can write it as 100 plus 3. 103 is 100 plus 3. Then put a square. This becomes a plus b whole square. So what is a plus b whole square? A plus b whole square is equal to a square plus 2ab plus b square. Now you substitute a as 100 and b as 3. 100 square plus 2 into 3 into 100 plus 3 square. So you get 100 square as 10,000 plus 600 plus 3 square is 9. So what is your answer? 10,609. I hope all of you understood this. Now if you want, you can write it as 101 plus 2 whole square also, not a problem. You can write it as 102 plus 1 whole square also. You can also write it as 99 plus 4 whole square also. But why we took 100 plus 3? Because we know 100 square directly. So easy. Now one more example. By using the identity, find 4p minus 3q whole square. So this is of the form a minus b whole square. You know that is a square minus 2ab plus b square. So let's substitute now. You will substitute 4p whole square minus 2 into 4p into 3q plus 3q square. Now when you simplify, you get 16p square, right, minus 2 into 4 into 3, 24pq plus 3q whole square is 9q square. So that's what your answer is. Now next question, again by using identity, you need to find 4.9 whole square. Now otherwise I know how to find 4.9 square easily, right? I will take it as 49 square, and 49 square, you know what is that? If you need to find 49 square, first step is minus 25, you will get 24. Next step is minus 50, you get 1. 1 square is equal to 1, so add 0. 2401, that's what 49 square. So when it is 4.9, you will put a point here, so 24.01. But here what they asked is by using the identity you need to find. So how will you use it? You can write 4.9 as 5.0 minus 0.1 whole square. 5 minus 0.1 is 4.9. Okay, so now you expand the bracket. This is going to be 5 square minus 2 into 5 into 0.1 plus 0.1 square. So 5 square is 25 minus 2 into 5, 10. 10 into 0.1 becomes 1. 1 minus 0.1 square. 0.1 into 0.1. So you'll get 0.01. So 25 minus 1, this is plus. Okay. 25 minus 1, 24 plus 0.01, 0.01. That's what your answer. Next question, again by using identity you need to find 3 by 2m plus 2 by 3n into 3 by 2m minus 2 by 3n. So this is of the form a plus b into a minus b, which is equal to a square minus b square. So how will you write now? This is a, this is b. So you will write it as 3 by 2m square minus 2 by 3n square. So what is your answer? 9 by 4m square minus 4 by 9n square. So I hope you understood it. Now one more question. By using identity you need to find 983 square minus 17 square. So if you observe here, this is of the form a square minus b square. So you can write it as a square minus b square is equal to a plus b into a minus b. So this you can write as 983 plus 17 a plus b into 983 minus 17. So this will give you 1000 and this will give you 966. When you multiply, you will get 966,000, and that's what your answer is. Now one more example. By using identity you need to find 194 into 206. So can you relate it to something here? If you observe here, you can write 194 as 200 minus 6 and 206 as 200 plus 6. Now this is of the form a plus b into a minus b. So if it is a plus b into a minus b, what is our answer? A square minus b square. So here your answer will be 200 square minus 6 square, and 200 square is 40,000 minus 6 square is 36. So when you do this calculation you get 39964. That's your answer. Now let's take the next identity that we have learned. What is that? X plus a into x plus b is equal to x square plus sum of 2, a plus b into x, right? A plus b into x plus product of 2, that is a into b. Let's take an example. Now you have an example in this question. You need to solve 501 into 502 by using identity. So you will write 501 as 500 plus 1, 502 as 500 plus 2. So this is of the form x plus a and x plus b. What is your answer? X square. So here x square means 500 square, right? 500 square plus then you have 500 as x. Okay, so the sum of this two, that is 1 plus 2 into 500 plus product of 2, that is 1 into 2. Now when you do this calculation, you get 2,50,000 plus 3 into 500, that means 1,500 plus 1 into 2, that is 2. So what is your answer? 2,51,502. That's your answer. Now let's solve one more example. 95 into 103. So using identity you need to solve it. What you will do? You will write this as 100 minus 5 into 100 plus 3. Now this is of the form x plus a into x plus b. Why? You can write 100 minus 5 as 100 plus minus 5, right? Then this is of x plus a. A is minus 5 here. Then 100 plus 3. B is 3. So let's substitute now. 100 square plus, you will write in bracket minus 5 plus 3, sum of 2 into 100 plus minus 5 into 3, right? Now let's simplify. This is going to be 10,000 plus minus 5 plus 3 minus 2. So minus 2 into 100 minus 200. So this is going to be minus 200. Minus 5 into 3 minus 15. So this is minus 15. So what is your answer? 9785. Now in this question or one more question, you need to simplify 2.5p minus 1.5q whole square minus 1.5p minus 2.5q whole square. Okay, now if you observe here, this term is coming here and this term is coming here. So if this is a minus b, this is b minus a. So let's supply this a minus b whole square minus b minus a whole square. Let's find this value. Okay, so let's find this value first. What is a minus b whole square? We know that a square minus 2ab plus b square minus, what is b minus a whole square? B square minus 2ab plus a square. Now let's open the bracket. A square minus 2ab plus b square minus b square plus 2ab minus a square. Now if you observe here, a square and minus a square is getting cancelled. Minus 2ab and plus 2ab is getting cancelled. Plus b square and minus b square is getting cancelled. So what you get is 0. So if you do a minus b whole square minus b minus a whole square, you will get 0. So if you do this operation, that is of the form a minus b whole square minus b minus a whole square. So the answer for that also will be 0. Why? Because b minus a is actually equal to minus of a minus b, right? See, if you open this minus symbol, this become minus a plus b, and if you rearrange, what you will get? B minus a itself. So b minus a is actually equal to minus of a minus b. So if b minus a is 1, b minus a is 1, minus a minus b will be 1. So a minus b will be actually minus 1. Okay, but what we need to do here, we need to take the square of it. So let's take the square of it. So this is going to be 1 and here also it is 1. But what we need to do here is actually, you need to after finding the square, you need to subtract b minus a square minus a minus b square, right? So that is 1 minus 1 will give you 0, and that's what exactly you got here. I hope all of you understood this. So if you want, you can always keep in mind a minus b whole square minus b minus a whole square is equal to 0. Now in this question you need to prove 4pq plus 3q whole square minus 4pq minus 3q whole square is equal to 48pq square. You need to prove this. Now how will you prove it? This is of the form a plus b whole square minus a minus b whole square, right? Now let's expand the bracket. So what is a plus b whole square? A square plus 2ab plus b square minus a square minus 2ab plus b square. So if you open this bracket, this is a square, this is minus a square, is getting cancelled. Then this is b square and this is minus b square. Why? This minus will go here. This minus will go here also. That is getting cancelled. What about this 2ab? This 2ab and minus 2ab will become plus because of this minus. So you will get actually 4ab. So a plus b whole square minus a minus b whole square is actually 4ab. So since this given expression is in the form of a plus b whole square minus a minus b whole square, your answer will be 4ab. And what are a and b here? This is a, this is b. So let's substitute a and b. 4 into 4pq into b is 3q. So 4 into 4 16, 16 into 3 48. Then p, okay, p is there, q and q, q square. So your answer is 48pq square. Hence it is proved.